Welcome back, guys. Now what we're going to do is we are going to talk about the difference between a monosaccharide and a disaccharide. All right? Now, in the previous chapter, we talked about monosaccharides, or in the previous video, we talked about monosaccharides. And here we have two monosaccharides that we talked about before. So this guy right here, it is glucose. All right, and remember, since it has 1, 2, 3, 4, 5, 6, then you know its formula is C6H12O6 because it should have the same amount of oxygen atoms and twice as many atoms of hydrogen, okay, as there is carbon. So we talked about that ratio, all right? And here we have the carbohydrate called, or monosaccharide called, fructose. Okay, and fructose also has 6 carbons, so its formula is C6H12O6. Okay, so now what I'd like you to do is take a little bit of time and build fructose and glucose. All right, guys, now if you build the molecules correctly, then glucose should look like this. Okay, with a hexagon. All right, notice your hydroxyl groups are down, one is up, one is down. You got your CH2 there. Okay, and then fructose looks like this. It has a pentagon. All right, it has the CH2 group below of the ring, the bottom part of the ring, and then this CH2 is on top. And so now we have our fructose and our glucose. So now they're like this, right? So what we want to do is, this is a monosaccharide. This is a monosaccharide. Now we're going to link them together to make a disaccharide, okay? So how do we do that? So the first thing is, notice we have to take out a water, okay? So part of this polymerization process is we have to take out a water. So in order for us to do that, we're going to take off one OH, so that's going to come out, and we're going to take one hydrogen. Okay, and that's going to come out, and notice 1, 2, there's our 2 hydrogens and the oxygen. And so that's how we're going to link them. But also the other piece is, okay, it's very specific where we're going to take off this hydrogen and this oxygen. So hopefully you have the fructose, okay, where you have your CH2 on top, and then this OH here on the bottom, that's the hydrogen you're going to take off. Right, so there it is, there's my hydrogen, right? Now, you want to take this glucose here, and see this corner carbon here? It should be opposite of that CH2. Now what we're going to do is we're going to take off this OH, and now that forms our water. There it is, right, water. So we took out a water, and that enables to make this glycosidic bond right there. And so now the 2 carbohydrates are bonded with an oxygen there, okay? And so this is carbon 2 in the diagram, this is carbon 1, and if you did it correctly, now this is a disaccharide. The disaccharide looks like this. So what is the name of this disaccharide? All right, well, this disaccharide is called sucrose. And what type of carbohydrate is it? Remember, it's a disaccharide because, because it's made out of 2 sugar molecules, or 2 monosaccharides, glucose and fructose, right? So now hopefully you understand, okay, the difference between disaccharides and monosaccharides, single sugar molecules. And when we take those single sugar molecules and you connect them, and now you have 2, this is called a disaccharide. Okay, the polysaccharide would be hundreds of thousands of monosaccharides linked together. So hopefully this helps. Okay, there it is, your sucrose molecule. This is actually the sugar that you eat all the time, and when it goes into your body, okay, your body breaks up this molecule, and this glucose goes into your cells, and your cells use it to recharge your batteries. So keep that in mind. Okay, disaccharide two monosaccharides linked together. All right, hope this helps. See you next time.